Hello everyone, it's Eddie the Magic Monk. Welcome to another maths tutorial. This is a problem solving question that you probably need to be pretty good with differential calculus in order to do it. So I would suggest you go through all of my differential calculus lessons, at least up to lesson 14 or 15 before you try this tutorial or this practice question. So what you have to do is, on the equation y equals x bracket x minus 5, so just looking at this equation you should be able to tell that it's going to be a quadratic because x times x is x squared after you expand it, and the highest power of x is squared, so it's going to be a quadratic. So on this quadratic equation or parabola, if a normal to the curve at x equals 6, so at x equals 6 you're going to draw a normal, which is a straight line that is perpendicular to the tangent line at x equals 6. If the normal cuts the curve again at point P, so we don't know where point P is right now, find the equation to the tangent at point P. Basically, we draw the curve, right? And that should help us solve some of these questions. So let's draw that. So we got the y-axis, the x-axis. So how do you sketch this curve? Well, if you understand a bit of quadratic equations, you should know that it should intercept the x-axis at 0 and 5. Alright, because the numbers inside the brackets represent the x-intercepts. And since there's nothing next to this x, it must intercept at 0. So let's draw a parabola. Let's see how good my drawing skills are. Pretty bad, but anyway, so the normal to the curve at x equals 6, so let's say x equals 6 is here. Alright, so this point is x equals 6, and the tangent at x equals 6, let's say that's the tangent. The normal is perpendicular to that, so let's say this is the normal. Okay, let's say this is the normal, and it cuts the curve again at point P. So let's call this point here point P. And that's our first goal, is we're going to find the coordinates of point P. Right? Before we have the coordinates of this point, there's really no way for us to keep going with this. So let's make that our first priority. Find the coordinates of point P. So what we're going to do is, obviously, we're going to find the normal equation, and in order for us to find the normal equation, we need two things. Firstly, we need the coordinates of this point. We only know that x is equal to 6 at this point, but we don't know what the y coordinate is. Alright, so let's find that first. So when x equals 6, if you substitute that number into this equation, we get y equals 6 times 6 minus 5, so that's 6 times 1, which is 6. So funnily enough, the y coordinate is 6 as well, so let's put a 6 there. Right, so both the x and the y coordinate is 6. Okay, so now we can try and find the gradient of this straight line. And if you guys remember, when you differentiate an equation, okay, so that is the equation y equals x bracket x minus 5. If we expand that, we get y equals x squared minus 5x. When you differentiate an equation, so y dash equals 2x minus 5. If you don't know how I differentiated that, you should probably go back to some other tutorials. So when you differentiate it, what you get is the gradient of the tangent. Gradient of the tangent. Alright, so the gradient of the tangent at x equals 6, all you got to do is substitute in the number 6 into the derivative. So y dash equals 2x minus 5 equals 2 times 6 minus 5, which is 12 minus 5, which is 7. So 7 is the gradient of the tangent. But we want the gradient of the normal at x equals 6 because we want the gradient of this line, which is the normal. So the way we would do that is we use the formula m1 times m2 equals negative 1. So two lines will the gradient of two lines, m1 and m2, will multiply together to give you negative 1 if the two lines are perpendicular, which is the case of the tangent and the normal, right? The normal is going to be perpendicular to the tangent. So we have the gradient of the tangent at this point, which is 7, right? This gradient of the tangent at this point is 7. So the gradient of normal will be, so let's say gradient of the tangent times the gradient of the normal is negative 1. So 7 times m2 is negative 1. So m2 equals negative 1 over 7, and that is the gradient of the normal. So this is the gradient of the normal. So what is the equation of the normal? Equation of the normal will be a straight line equation, wouldn't it? Because it's a straight line, and all straight line equations are mx plus c. So we have the gradient, so let's put that in, negative 1 over 7x plus c. And then all we need to complete the equation of the normal is the y-intercept, c. So in order for us to get that, what we're going to do is we're going to substitute in the x and the y coordinate of this point, because we know that the normal is going to pass through this point, and we know the gradient of the normal. So using that, we can work out the equation of the line, equation of the normal. So when x equals 6, y equals 6 according to our graph, according to what we worked out previously. So y is equal to, so 6 is equal to negative 1 over 7 times 6 plus c. And if we work that out, 6 equals negative 6 over 7 plus c, combining these two terms together. Then we got 6 plus 6 over 7 equals c. Right, moving this to the left. So now we have c is equal to 6 and 6/7 is equal to c. So the gradient of the normal, it will be, the equation of the normal is going to be y equals negative 1 over 7x plus 6 and 6/7. So just to make sure that we have that correct, I'm going to show it to you on Desmos, my favorite graphing calculator. So that is my equation, my curve. And if I draw in y equals negative 1 over 7x plus 6 and 6/7. So how do you enter that? Oh, well, just going to go 48 over 7. Right, because 7 times 6 is 42. 42 plus 6 is 48. So these two fractions are equivalent. So you can see here the normal passes through this point, and there's the normal, and basically we just want to find out what that point is. That's our answer right there, but we got to prove it using algebra. So now let's have a look at the equation again. So it says if the normal to the curve cuts the curve again at point P. So we now have to find point P. And point P is the intersection between this curve and so between this curve, which is represented by this equation, and the straight line, which is the normal. So we got to copy down both equations. So we have, let's work over here. Oops, not enough space. Y equals x bracket x minus 5. So we got y equals x bracket x minus 5. That's my curve. And y equals negative 1 over 7 x plus 6. And 6 over 7. That's my normal. These two things, we need to find out where they intersect. So what we need to do is we need to understand that at the point of intersection, both y coordinates are the same. So let's make them equal to each other. So we can substitute this expression into where the y coordinate is in the other line. So we have x bracket x minus 5 equals negative 1 over 7x plus 6 and 6/7. So we got to expand everything out. So x squared minus 5x equals negative 1 over 7x plus 6 and 6/7. Now let's move everything to the right. So 0 equals x squared, a negative x squared plus 5x minus 1 over 7x plus 6 and 6/7. And let's combine these two terms in the middle. So negative x squared plus 5 minus 1/7 is 34 over 7x plus 6 and 6/7. Now you need to in order to solve for x, which is where the two lines will intersect, you then need to use the quadratic formula, right? Because there are 3 terms here. There's no way for us to solve it without using the quadratic formula, because they're not whole numbers. So that number here is a, so this is negative 1 is a, and b is that, and c is that, that's b, that's c, and so on. So let's put all that into the quadratic formula, and we will get 6 or negative 8 over 7. And you can see from our curve that is exactly where the two lines intersect, right, at these 2 points. X equals 6 and x equals negative 1.143, which is the same as negative 8 over 7. So what we're going to do now is we know the x coordinate of this point here, negative 8 over 7. So point P is negative 8 over 7, and we want to know the y coordinate. So the way we would do that is we would simply put in negative 8 over 7 into either the normal equation or the parabola equation, doesn't matter. So y equals x bracket x minus 5. Let's put in negative 8 over 7 into x, negative 8 over 7 minus 5, and let's put that into the calculator, and we will get 7.02, which is what it says on the graph, but if you want it in fraction form, it's 7 and 1 over 49. Okay, if you have a fraction button on your calculator, that will help you get that. So it's 7 and 1/49. So now that we have that point, we can work out the tangent at point P. So how do we get the tangent equation? All right, how do we get the tangent equation? Well, previously we've worked out that the gradient of the tangent, which is the derivative, is y dash equals 2x minus 5. So let's copy that down. So we got tangent equation is y equals mx plus c, because it's a straight line. M is equal to y dash at x equals negative 8 over 7, right? That's the x coordinate of that point. So y dash when negative 8 over 7 is the input. So the gradient equation is 2x minus 5. Confirm that one last time. Yep. So it's 2 times negative 8 over 7 minus 5. So let's now put that into the calculator. And the answer is negative 51 over 7. And that is the gradient of the tangent. So continuing from here, we have y equals m, which is negative 51 over 7, x plus c. In order to work out c, we're going to substitute in the coordinates of point P. So the coordinates of point P, which is negative 8 over 7 for x, and 7 and 1/49 for y. So 7 and 1/49 for y equals negative 51 over 7 times x is negative 8 over 7 plus c. Okay, so a whole lot of fractions, so let's work that out. C is equal to 7 1/49 minus all that stuff. So 51 times 8 over 7 times 7. So let's put all that in and see what C equals. And the answer is negative 64 over 49, which is the same as negative 1 and 15/49. So it's negative 1 point something. Okay, so what is the equation expressed as a whole thing? So it'll be negative 51 over 7 x plus or minus 1/15/49, and that is the full answer to the whole question. Alright, find the equation to the tangent, and that is the equation of the tangent. Now you might want to express the fractions as mixed number fractions, so in that case it'll be negative 7 and 2/7. So let's draw that on our Desmos. Right, if I draw in the equation negative y equals negative 7. Oh, how do you draw mixed number fractions on this? I'm just going to keep it to improper fractions. Negative 51 over 7 x minus 1 and 15/49, that was negative 64 over 59. So, and you can see the green line is the tangent to the curve at this point, right? If I zoom out a bit, you can see it. Okay, it's a tangent to the curve at this point. So, yep, I think we have the right answer. Okay, thanks for watching, guys. Hope you have learned something from this tutorial. Very long question. Okay, hopefully once you've done this, you'll be more confident with calculus. See you next time.